Hello and welcome to the Robot Moose YouTube channel. Let's talk about Astra. This is the first video in the video series I'm calling Catching Up on LUMINSim, where we'll go over the simulator's existing features together to get caught up to speed. Because these features existed before this channel, videos in this series will be shorter than the active development videos I plan to make in the future, where we'll clean up existing features and add new ones. Astra was the first candidate for the Aurora Robotics Lab's LAMP concept. Not that kind. I'm referring to LAMP, or Lunar Autonomous Modular Platform. LAMP will be a robot that is highly capable on the moon, very modular, autonomous, and highly manufacturable. Its purpose will be to act as the hands, so to speak, of the LUMIN system. Quick reminder, LUMIN stands for Lunar Mining and Infrastructure Network, and is the control system for lunar operations. Continuing with the hands analogy, LUMIN is sort of like the brain. LUMIN and LAMP will enforce safety protocols, develop lunar infrastructure, coordinate communication, and more. Groups of LAMPs in the field will work together to do things that would be extremely difficult or even impossible for a single robot to accomplish on its own, like complex construction tasks. LAMP's design revolves mainly around versatility. It has to be capable of a massive variety of tasks on the moon, and we think that specialized tasks should be handled with modular attachments designed for each task that can be easily interchanged, and that way LAMP can remain simple and highly capable across many contexts. That sort of design philosophy keeps manufacturing costs and complexity down, while also encouraging simpler and more durable and repairable parts, and as a whole will promote wider adoption across the lunar surface and promote universal standards in lunar infrastructure. If you watched our intro video, you will have seen that Astra is already in LUMINSim. LUMINSim actually serves as our way of testing our new robot designs, which includes Astra, who was the first candidate for the LAMP system. It turns out Astra has some major flaws. First, its built-in hopper for regolith severely limited its modularity. What if we wanted to put a flatbed or a communications relay or something else? As it's designed, we simply can't do that. Second, the point where Astra's arm meets the frame is too far forward. As you can see here, this makes Astra very prone to tipping over, and once tipped, it struggles to right itself without intervention. Even though Astra had some pretty major flaws, it still gave us a lot of insights in how we might develop future LAMP candidates. Here's what we did to get Astra into LUMINSim. Astra was designed in Fusion 360, so we first exported each part as an OBJ 3D model and corresponding MTL material files. Each part was then dragged into Godot and scaled to match the real-world size of the robot. Then we added its joints. Astra has an arm, a bollard, and a rotating tool coupler, and those all need to be able to rotate and actuate. It also has two dirt hopper doors that need to actuate in a similar way. Godot's built-in hinge joint 3D nodes are not responsive enough to simulate Astra's linear actuator-driven joints, and they turn out to be very buggy joints to work with. So I made the Better Hinge Joint 3D component. It extends Godot's generic 6 degrees of freedom joint, which allowed me to manipulate the joint's limits directly on any axis, and this made Astra's joints responsive and very easy to set up. Those same joints were actually used also on the implementation of Xcohauler, which we will talk about at some point in the future. Even after making Better Hinge Joint 3D, it still had some issues, like the floppy noodle joint problem, which seems to happen for no reason. As such, I plan to remake the component entirely and just manipulate the node's transforms directly. As you can see in this clip, Astra's arm is able to pick up tools. The way that we accomplish this is with what we call the connector component. I designed this connector component to be able to identify other connector components when they enter their area. When this happens, they handle passing information about their attached nodes to each other. Extending the connector component, I created a tool connector component which allowed me to use this passed information to also instantiate a joint between the two connector nodes when the user presses a key. Speaking of pressing keys, the user input system right now is not ideal. It just uses if statements in the process loops, as you can see. This causes some pretty major issues in performance and makes code complexity much higher than it needs to be. So in the future, when we develop more autonomy together, we'll work on centralizing inputs from all input sources, so from an autonomy component and from the user, into a single place and get rid of those if statements entirely. Using a bucket attachment, Astra is able to dump dirt into its own hopper. By default, dirt balls despawn after some time of not turning back into terrain, so both Astra's hopper and the bucket attachment turn off despawning for dirt balls inside of them. In the future, I'll also talk about how the dirt ball and terrain system work. But right now, in short, it is a height map, and we use approximated volumes to spawn dirt balls corresponding to the amount of terrain that we dig out. And that digging out works by detecting the velocity of the bucket coming into the terrain, which then lowers the height map to that spot in the terrain. There's also corresponding angle of repose logic, and all that means is the angle at which the dirt will begin to slide on its own. If you've ever poured a pile of dirt onto the ground and seen the clear angle that forms at the edge of the hill, that is that material's angle of repose. So what we did is we used data from real lunar dirt picked up in the Apollo missions to figure out the angle of repose of the dirt on the lunar surface, and we implemented that into the simulator. Coming back to Astra, the frame of Astra is a vehicle body 3D and acts as the Astra scene root node. It drives using vehicle wheel 3D nodes, which are Godot's built-in wheels for the vehicle body 3D node. We will probably design a custom component for wheels at some point too, because these nodes just don't do a very good job of simulating the style of gearbox-driven wheels we have. On the back of Astra's frame is another connector component, as you can see. Right now it just serves as a charging connector for LUMINSim's power system, which will also be discussed in a future video, but in the future it may be extended to act as a trailer hitch in future lamp designs. As of now, that's all there is to know about Astra and the LAMP system. To see more detailed information about both LAMP and Astra, head on over to their corresponding wiki pages linked in the description below. If you have any questions, comments, or suggestions, please leave them in the comments section below as well. Hey, Editor Andrew here. Quick reminder, if you go ahead and head over to our Patreon page, that is the best way to support our work and continue us making these cool things. Until next time.
Yes. You are the dirt ball.